Okay, I'm going to finish the rest of this sample free response question. So here was the question, and we went over parts A and B and quickly over C, so I'm going to discuss that one a little bit too, but we didn't get a chance to go to D. So for this, part A, the answer was there was a relative max at x equals 2. Remember, the key to this problem was recognizing that f, the antiderivative of that was this new function g of x, therefore f of x must be g prime of x. So since we have g prime of x, if we want max or mins for g, we have the information from the graph and we get the relative max at x equals 2. We think of the tangent lines to this graph to determine concave up and concave down, which is the second derivative, and we get the following intervals of concave up. Alright, so for part C for this problem, we had to determine the limit as x approaches 0 of g of x plus 1 divided by 2 of x. So remember, whenever we evaluate a limit, the first thing we try to do is just plug it in. So that means we have to do g of 0 plus 1 over 2 times 0. Well, we already see that we get division by 0, which is a problem, but before we can go any further, we really need to know what's going on in the top. So we have to evaluate g of 0. Well, to find g of 0, we need to, sorry about that stray mark, here we go. We need to realize that we need to use integration to find it, because this is how we get to g from the antiderivative of f. So the antiderivative of f of x from 0 to 3 is what we want to use, and we want to use the interval from 0 to 3 because we're trying to find g of 0, and we know g of 3, because when we evaluate this definite integral, that would be g of 3 minus g of 0. So this expression on the left, we need to realize that that represents the area under f of x from 0 to 3. We were given information about the areas. So this was 5, and under D was 3. So that allows us to replace this expression with the value 8. We know g of 3 is 7. We only have our unknown, which is g of 0. So we can solve this, and we see that g of 0 is negative 1. So now when we go back to that limit, we replace g of 0 with negative 1, and you see we get 0 over 0. That makes this limit indeterminate. When it's indeterminate, we can use L'Hopital's rule, which means that this limit now turns into g prime of 0. The derivative of 1 is 0. The derivative of the bottom, which is the expression 2x, is just 2. G prime of 0 we can get from the graph. It's that point right there. So we get 0 over 2, which is 0. So the answer for C, the limit, would be 0, and we use L'Hopital's rule. Alright, now we're going to look at part D of this problem. So we're trying to find this value, the definite integral of this new function that's called h of x. So I rewrote it. I brought the 3 out front. So we're trying to find this integral. Alright, and then I realized that this I can split up. like that. And that's also -2 to 1. So this last integral right here, that one's no problem, I can handle that. This one, when all the information I have is here, I need to do a little thinking here. I need to actually rethink of this in terms of a simpler function, so I'm going to call it f of u. But I need to define that u, so in other words I'm going to use u substitution. So I'm going to let u equal 2x plus 1, and then du will equal 2dx, so 1/2 du equals dx. So this, I'm just working on this part right now. So this will turn into 3/2, the antiderivative. I'm going to change these values of integration. When x is -2, u will be -3. And when x is 1, u will be 3. And that will be f of u du. So now I can use or evaluate this using the graph up here. Would be the area from -3 to 3. So it'll be 3/2. And remember, we were given these values. It was 5, 4, 5, and 3. So this will be 5 plus 4 plus 5 plus 3. And now this other part, the antiderivative of 4 is 4x. And I don't need to change these values of integration because this is still in terms of x. So it'll be 4 minus -8, which will turn into 4 plus 8. So this will be plus 12. And I do this calculation, I end up with a value of 25.5.